Hello, hello, can you hear me? Hello, 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 hello. Yes. ಕ್ಲಾಸ್ 10 ಸ್ಟೇಟ್ ಆ್ಯಂಡ್ Cbse ವಿದ್ಯಾರ್ಥಿಗಳು ನಮಸ್ಕಾರ ಸ್ಥಿತಿಗೆ ಬನ್ನಿ. ಇಷ್ಟ ದೇವತೆಗೆ ಗುರು ಹಿರಿಯರಿಗೆ ಪ್ರಾರ್ಥನೆ ಸಲ್ಲಿಸಿ ಇಂದಿನ ಎಲ್ಲ ಅಭ್ಯಾಸಗಳನ್ನು ಏಕಾಗ್ರಚಿತ್ತದಿಂದ ಶಾಂತ ಮನಸ್ಸಿನಿಂದ ಮಾಡಿ ಮುಗಿಸುವ ಶಕ್ತಿಯನ್ನು ಕೊಡಲು, ಕಲಿತ ವಿಷಯಗಳನ್ನು ಜ್ಞಾಪಕದಲ್ಲಿಟ್ಟುಕೊಳ್ಳುವ ಶಕ್ತಿಯನ್ನು ಕೊಡಲು, ಜ್ಞಾಪಕದಲ್ಲಿರುವ ವಿಷಯಗಳನ್ನು ಪರೀಕ್ಷೆಯಲ್ಲಿ ಸರಿಯಾಗಿ ಬರೆಯುವ ಬುದ್ಧಿಶಕ್ತಿಯನ್ನು ಕೊಡಲು ಇಷ್ಟ ದೇವತೆಗೆ ಗುರು ಹಿರಿಯರಿಗೆ ಕುಲದೇವರಿಗೆ ಪ್ರಾರ್ಥನೆಯನ್ನು ಸಲ್ಲಿಸಿ. ಟೇಕ್ ಡೀಪ್ ಬ್ರೆತ್ಸ್. Yes, good evening, my dear students. Good evening, welcome. Good evening, Satvik. Okay, we are in the last period of the chapter, first chapter, chemical reactions and equations. First chapter, be ready for a test. Chemical reactions and equations. We completed the redox reactions and equations. Okay, we have to focus on questions and studied the last type of reaction in the last class, that is redox reactions. We discussed about redox reactions, and today we are left with the application of oxidation reaction in the daily life, like corrosion. We have to learn corrosion and rancidity. Corrosion of metals, rancidity. Corrosion of metals, rancidity of oils and fats. If you discuss this much, chapter will be completed. See, in the redox reactions, we took some examples. Okay, now let us see the reaction again. The zinc oxide solid plus carbon solid, when treated, it forms, you studied, zinc solid plus carbon monoxide gas. Why I am taking this reaction is, which one is oxidized here? Zinc oxide is converted to zinc, carbon is converted to carbon monoxide. They will give one question like this. You will be asked 4 questions in it. Which is oxidized? Which is reduced? Which is oxidizing agent? Very important. Your question will be, which is oxidized? Which is reduced? Identify which is oxidizing agent, and which is reducing agent. So last class we studied what is oxidized, what is reduced. I hope you have clear understanding of what is oxidized, what is reduced. Now we have to learn what is oxidizing agent, what is a reducing agent. You know, in a daily life, you know what is LIC agent? What agents will do? There are many agents. Agencies are there. What agents do? Agents will support. LIC agent will support to get the LIC policy. Similarly, oxidizing agent is the one which supports the oxidation. Observe here. Which is oxidized here? Carbon is oxidized. Carbon is oxidized. Means in order to oxidizing agent is the one which helps the oxidation by providing what? Oxygen to it. Now, for the, this is, you know that carbon gains electron, gains oxygen. Here zinc oxide loses oxygen. We said that oxidation can be memorized as plus addition of oxygen is oxidation, removal of hydrogen is oxidation. Reduction can be simply memorized by this memory map as reduction can be written as addition of hydrogen minus removal of oxygen. Observe what happened here. In case of zinc oxide, it will lose the oxygen, means removal of oxygen takes place. Removal of oxygen takes place means this reaction is reduction. This reaction is reduction. And carbon gained oxygen. Therefore, this reaction is oxidation reaction. As both reactions are taking place, we call it as red ox reactions. Both reduction as well as oxidation takes place. Such reactions are called as redox reactions. I hope you are clear with this without any confusions. Now, the question is oxidizing agent. Oxidizing agent is the one which itself undergoes reduction and supports the oxidation of other, which is itself undergoing reduction. Zinc oxide is undergoing reduction, right? Therefore, oxidizing agent will support the carbon to get oxidized by providing one oxygen to it. That is called as oxidizing agent. You can understand oxidizing agent as the reagent which itself undergoes, remember, which itself undergoes reduction and helps other reactant to get oxidized. Observe, by this definition of oxidizing agent is called, note down the definition clearly, is called oxidizing agent. Remember, note down the definition. What is oxidizing agent? The reagent which itself undergoes, underline the word reduction, and helps the other reactant to get oxidized. Now, which is undergoing reduction here? Zinc oxide is undergoing reduction. How it helps carbon to get oxidized? For carbon to get oxidized, it should gain oxygen. Therefore, it is helping carbon to get undergo oxidation. Therefore, which is oxidizing agent here? Oxidizing agent is zinc oxide, obviously. Understand it. Clear? Any doubts in this? Similarly, how can I define reducing agent? With common sense, you can write. How can I write reducing agent? The reagent which itself undergoes oxidation. Very important general definition. Itself undergoes oxidation and helps other reactant, reactant to get reduced, is called reducing agent. Now observe, which itself undergoes oxidation. Which is undergoing oxidation? Carbon is oxidized to carbon monoxide. It is helping, itself undergoes oxidation and helps other reactant to get reduced. Which is reducing here? Zinc oxide should be reduced to zinc. Means to undergo reduction, it should lose what? Oxygen. Therefore, to lose oxygen, carbon is helping it. Therefore, carbon is obviously considered as reducing agent. Remember, oxidizing agent, reducing agent, clearly. You want my introduction? Okay. Myself is Sivaraj Desai, sir. My name is Sivaraj Desai, sir. Sivaraj Desai, right? I'm the founder of the institution called as Lokagnana Tutorial Institute. I ran it for 22 years, right? Students call me as a Desai, sir. I am teaching more than 27 plus years for class 10th, PUC1, PUC2, 8th, 9th, 10th, PUC1, PUC2, chemistry, maths for more than 27 plus years. This much introduction is sufficient. My main introduction is, you listen to my class. If you like my class, that will be my introduction. Okay? Student call me as Desai, sir. I am in Gadag, Karnataka. I started my own institution, coaching center for competitive exams, PUC1, PUC2, 8th, 9th, 10th, for all streams, state, Cbse, ICSE. I taught chemistry and mathematics for more than 27 plus years. Okay? I think that much is sufficient, my introduction. And remaining things about me, you can understand in my class only. I hope you got it. What is oxidizing agent and what is reducing agent? Now I will give another example. You identify which is oxidized and which is reduced. I will take a different example than I discussed in the last class. Take this one. I will give the reaction, you try to balance it. Manganese dioxide. You write formula. Manganese dioxide plus hydrochloric acid. Hydrochloric acid gives rise to manganese chloride, manganese chloride plus chlorine plus water. Write the equation and balance it. Write the formula and balance it and identify what is oxidized, what is reduced, what is oxidizing agent, what is reducing agent. Another example on redox reaction. Manganese dioxide. Di means 2. Manganese, whenever you say manganese, its valence will be plus 2. Dioxide will have the formula O2. Manganese can have variable valencies. Here valency of manganese will be plus 4. Manganese dioxide formula is MnO2. It is a solid. Hydrochloric acid, HCl. When you add hydrochloric acid, liquid hydrochloric acid, you will get a manganese chloride. Whenever manganese chloride is given, you have to take the valency as a plus 2, minus 1. You can write the formula as MnCl2 plus chlorine will be gas plus H2O. Balance the equation. To be in accordance with the law of conservation of mass, you have to balance the equation, right? Start with balance metals first. Metal is manganese here. then you balance chlorine, then you balance hydrogen, or you can balance hydrogen first, lastly you can balance that element last which is occurring more number of times. In two compounds it is coming, therefore balance it at the end. Manganese 1 atom, manganese 1 atom. After balancing we'll think of oxidation and reduction. Yes sir. What happened here? Now manganese atoms are balanced. Next, hydrogen atom. How many hydrogen atoms on the left? 1. How many hydrogen atoms on the right? 2. Therefore to balance it, let me make it as 2HCl. I hope you understood. Now the question is, then you balance oxygen, lastly you can balance chlorine. How many oxygen atoms on the left? 2. How many oxygen atoms on the right? 1. Therefore you make it as 2H2O. Now oxygen atoms are balanced, but hydrogen atoms are disturbed. How many hydrogen atoms? 4 hydrogen atoms, but there are only 2 here. Therefore I must take it as 4HCl by hit and trial method. This is the basic thing. You learn it correctly. If you are not learn it, in my same channel, Lokji channel, in the bridge course, videos are available. Watch them. How to write formula, how to balance equation. In detail I have discussed. Manganese chloride. Now 4 chlorine atoms, there are 2 plus 2, 4 chlorine atoms, and the equation is balanced. Now to identify which is oxidized. My question is, which is oxidized, which is reduced? Okay, and with the arrow marks, with the diagram, we will draw it. I will remove this verbal equation. After writing verbal equation, you have to write skeletal equation, means unbalanced equation. Then you balance it by using hit and trial method. Now you can observe that manganese chloride is converted into manganese dioxide is converted into manganese chloride. Here there is loss of oxygen. Loss of oxygen. And hydrogen chloride is converted to what? Chlorine. What happened here? What happened here? Hydrogen has lost, this particular reaction has lost hydrogen. What is happening? Loss of hydrogen or gain of hydrogen? Loss of hydrogen or gain of hydrogen? Yes. Now the question is it a redox reaction? Is the question. Which is oxidized, which is reduced? Loss of oxygen and loss of hydrogen. What is the definition of oxidation reaction? Oxidation reaction, let me remind you, addition of oxygen or removal of hydrogen. Right? What is reduction reaction? Reduction reaction is addition of hydrogen or removal of oxygen. Which is oxidized, which is reduced now? Removal of oxygen is taking place in MnO2, therefore you can call it as reduction. Loss of oxygen. And removal of hydrogen is taking place in HCl, therefore you can call it as reduction. Removal of hydrogen is called as oxidation. Minus hydrogen, 1 hydrogen is lost there. Here oxygen is removed. Removal of oxygen is called as reduction and removal of hydrogen is called as oxidation. Okay. Now you can tell me which is oxidizing agent. Which is oxidized? You can write oxidized. Oxidized substance is HCl. Reduced substance is reduced substances oxidized substance is HCl, reduced substance is MnO2. Now tell me, what is oxidizing agent? Just now we studied what is oxidizing agent. Remember one word correctly. Oxidizing agent is the one itself undergoes reduction. Which is undergoing reduction? MnO2. Therefore, you can directly say that MnO2 is oxidizing agent. Itself undergoes reduction. And what is the reducing agent? Reducing agent itself undergoes what? Itself undergoes oxidation. Which is undergoing oxidation? HCl. Therefore, you can directly say that reducing agent is HCl. I hope the things are clear to you. Oxidized substance is HCl, reduced substance is MnO2, oxidizing agent is MnO2, reducing agent is HCl. I hope you understood. I'll give another example. You have to identify similarly. Last example to complete redox reactions. See, I will take Fe2O3 solid plus carbon monoxide gas. I will write a little below so that I can show arrow mark. Fe2O3 is solid plus carbon monoxide is gas. It will form. Shall I rub this one? I hope you understood this. Now again you have to identify what is oxidized, what is reduced, what is oxidizing agent, what is reducing agent. You will get the product is iron plus carbon monoxide is converted to carbon dioxide. This is the skeletal equation I have written. You balance it now. Fe2O3 is called as ferric oxide. What is the name of it? Ferric oxide or iron 3 oxide. This one is called as carbon monoxide. You can understand products easily. Monoxide, that is iron and carbon dioxide. Now, which is oxidized here? Iron oxide is converted to what? Iron oxide is converted to iron. Here carbon monoxide is oxidized to converted to CO2, right? Here in this case, what is involved? Fe2O3 is converted into Fe means loss of oxygen. Here, what is happening? Gain of oxygen. Therefore, which is oxidized, which is reduced? Loss of oxygen is called as reduction. Gain of oxygen is called as oxidation. Now go on writing the 4 answers. Have this habit. First one is the substance oxidized. You will be asked, what is oxidized in this case? Carbon monoxide is oxidized to carbon dioxide. You can write the reagent as carbon monoxide gas is oxidized. Which is reduced? Try to identify which is reduced. The one reduced is Fe2O3. Ferric oxide is reduced. Important question is, many students confuse it. Oxidizing agent. Ille mistake ಮಾಡ್ತೀರಿ ಬಹಳ ಮಂದಿ. You are doing mistake. And fourth one is reducing agent. Just to remember, reducing agent. What is reducing agent? Oxidizing agent is the one which itself undergoes what? Reduction. Therefore, oxidizing agent is the one which undergoes reduction. Which is undergoing reduction? Fe2O3 is considered as oxidizing agent. Reducing agent is the one which itself undergoes oxidation. Very simple. Carbon monoxide. That's all. If you write these questions, you will score marks. I have seen number of students, unnecessarily students get confused. You have my idea. Oxidizing agent is the one which itself undergoes reduction. Which is undergoing reduction? Ferric oxide. Reducing agent is the one which itself undergoes oxidation. I hope the points are clear to you. Okay. Now, coming to, see, in the modern days, it was old definition. Loss of oxygen, gain of electrons. All of you understood this. Yes, yes, Satvik, correct. क्या मैं अच्छे से नहीं पढ़ रहा हूं क्या? पढ़ा रहा हूं क्या? ओके, दैट्स योर प्रॉब्लम, नॉट माय प्रॉब्लम. Okay, yes, continue with see electronic definition. Nowadays, this is old definition. Electronic definition, remember electronic nowadays, electronic after the discovery of electronic definition, just I will introduce you so that it will help you. See, generally, if I take the same example, when iron is treated with copper sulfate, you will get copper is deposited and iron is converted into ferrous sulfate. Now look at the valency of it. Generally, atoms will have valency 0. Getting me? And copper will have valency +2. And this copper will have valency 0. Here, valency of iron is ferrous is +2. Now observe, what is the conversion here? From 0 to valency became +2. Cu +2 valency is converted into copper 0. I will show you the change, electronic change. Fe to convert it into Fe +2, what should happen to it? It should lose how many electrons? 2 electrons. For Cu +2 to convert it into copper, it should do what? Gain of electron to become copper. And here what is happening? Iron is losing electrons, loss of electrons. Remember, loss of electrons. And here gain of electrons. Here gain of electrons. Gain of electrons. Okay. See, according to modern electronic definition, remember, just I will give you one example. Modern definition, right? A reaction which involves a loss of electrons is called as, remember, oxidation. Just for your reference, I am telling you, not there in your state and Cbse syllabus. The reaction which involves gain of electrons is called as reduction. That's all I wanted to tell you. Just one example you take, write it. If the loss of electrons is there, it is called as oxidation, because iron is converted into Fe +2. Here you have loss of how many electrons? 2 electrons. Next year you will be learning in the 11th standard in detail. Here gain of how many electrons? 2 electrons. This is a modern definition of oxidation, loss, reduction, loss of electron, reduction, gain of electron. Means all reactions do not involve only oxygen and hydrogen. If in a reaction oxygen and hydrogen are not present, how do you check whether it is oxidized or reduced? That can be checked by loss of electron and gain of electron. Therefore, this old definition is left now. Modern definition is taken. That you will be learning in the 11th standard, first PU, under the chapter oxidation number. I will not go in detail for it. Just for your reference, I have told you. Let us move on to the last part, that is corrosion. Corrosion of metals. See, corrosion of metals. Corrosion of metals. You do one thing, you take one iron, strip of iron and throw it in air, moist air, in air for one season. for one season, what happens? You observe. Take a copper vessel and keep it exposed to moist air. Copper vessel, iron sheet, copper vessel exposed to moist air. Moist air. What happens to it? Take a new silver chain and wear it. Silver chain, wear it. When exposed to air, it will be very shiny. What happens? When iron nail or iron sheet is exposed to air for one season, it will develop over a long period. It will develop a reddish brown colored coating. Reddish brown colored coating on it. Reddish brown colored coating on it. And popularly it is known as rust. What it is called as? Rust. The process is called as rusting. And generally when copper vessels are kept in moist air for a long period, it will develop a green color. Remember, copper undergoes reaction. Moist air consists of oxygen, water and carbon dioxide. All these will attack. Even hydrogen sulfide will be present in the air. Attack. And silver on exposure to air. You must have seen when you bring the silver chain, and it will be very shiny. After some times you can see the silver, it will be tarnished or develops a black colored coating, black coating on it. And these are the observations made in a daily life. This property of the metals, right? Generally the metal iron will be lost by this. The metal copper will be lost by this. The silver metal will be lost by this. This particular loss of metal due to combined action of constituents of the environment is called as corrosion. You can define corrosion now. These are the examples of corrosion of the metals. Corrosion is defined as the loss of metal. The loss of metal. Hello, hi. I don't know your name clearly. Please save your name. Tell your name. The loss of metal due to combined action. Due to combined action of constituents of environment. Constituents of environment. By constituents of environment is called as corrosion of metals. You can take 3 examples. We'll write reactions for them. Because iron will react with oxygen and water present in the air and converted into reddish brown colored rust. As a result, iron will be lost. Copper on exposure to moist air, it will react with carbon dioxide, oxygen and water, turns into green colored substance. Silver, when exposed to air, right, it will combine with the hydrogen sulfide of the air. It will form a silver sulfide. And this copper will react with carbon dioxide and water present in the air, and it is converted to what? It is converted to copper carbonate, green colored copper carbonate. Clear? I hope you are getting me. Let us write the reactions for them. For each one of them, take the examples of corrosion and we'll write the reactions for all the 3 of them. How they get rusted, what chemically rust is. See, what happens is, when we'll take one by one. when iron is exposed to air, this is iron solid. When exposed to air, it will combine with oxygen present in the air, and x number of water molecules, because different samples of iron will have different number of water molecules, therefore this is variable. It depends upon the nature of the iron and impurities present in it. Therefore it will take up a different number of water molecules, therefore we write it as X. Forming a product, reddish brown colored product, we call it as hydrated ferric oxide. We call it as hydrated ferric oxide. Write the name of it, ferric oxide. Write the reaction taking place during corrosion of the iron. If you ask, you can write this reaction. How many oxygen atoms are required there? 3 oxygen atoms. Let me take a 3/2O2. How many iron atoms are required? 2 iron atoms. And the equation will be balanced. So this is what is called as rust. It will have reddish brown color. Means once it is converted to this, iron is used up, the original property, metallic property, iron will lose slowly. You must have seen old drums of iron, rusted drums, they are wasted. Means the loss of the metal takes place by converting it into reddish brown colored ferric oxide. Similarly, copper, solid, pure copper, when you expose it to moist air, it reacts with carbon dioxide and oxygen present in the air, and it forms a carbonate. We call it as basic copper carbonate, which has formula CuCO3 CuOH twice plus H2O. You can write the equation and balance it. CuCO3. CuCu, there are 2 carbon atoms, therefore you can take 2 Cu. There is 1 carbon atom, you can write 1 carbon atom. Oxygen atoms are 2, hydrogen atoms are 2, oxygen atoms are 3 plus 2, 5, 2 2s are 4, 4 plus 1, 5. This is called as basic copper carbonate. It is written as basic copper carbonate, and it will have the green color. Once it develops the green color, you must have seen inside the copper container, a green colored coating will appear in the vessels you are using for puja. If it is kept in the air, moist air, for a long period, it will develop a green colored. That green colored basic copper carbonate is formed. As a result, copper will lose its original property. That is a second example and reaction. Third one, what is the reason for silver? Silver chain, when you purchase it fresh, it will react with hydrogen sulfide gas present in the air and forms a silver sulfide, Ag plus 1, S minus 2. You can write Ag2S plus S2. Balance the equation. Plus S2. Right? Balance the equation. That is 2 Ag. And sulfur is 1 atom hydrogen, and because of this silver gets what? Tarnished, and this will have the black color. Silver sulfide will have the black color. It is called as silver sulfide. Look at the name of it, IDE. Binary compounds end with IDE. Silver sulfide is formed. I hope you understood corrosion of metals, loss of metal. I'll repeat, loss of metal due to combined action of the constituents of the environment like oxygen, water, carbon dioxide, hydrogen sulfide. The loss of metal takes place. It is called as rusting. The chemical reactions taking place during rusting also I have clearly shown you, which is not in your textbook. And now the question is how to prevent this particular rusting or tarnishing. Prevention. Particularly to prevent it, you must coating of coating of some barrier. You have to coat a barrier. Barrier means which will protect the metal from the exposure to direct attack of these particular constituents of the environment. One method is, particularly iron, is painting on it. Oil painting, not the ordinary painting. Oil painting can do the job. If you paint the oil painting on the surface, then you can prevent it. Particularly iron can be prevented from rusting. Your gates and your window panes, they should be maintained every year by painting. If the paint on the desk also, metal desk, they also rust if the paint goes. Again you have to paint it. Oil painting, or even you can coat the oil or grease. Greasing can prevent the job. And there is another method called as electroplating. You know, electroplating is an electrolysis process. Means giving a coating of metals like tin, called as a tinning. It is called as tinning. Zinc, called as galvanizing. Remember, iron can be prevented from rusting by galvanizing. And giving a coating of aluminum or giving a coating of chromium, called as chrome plating. Aluminum is a self-protecting metal. Therefore, aluminum never rusts. So these are some of the methods of preventing this particular oil painting or oil greasing, electroplating, or coating the metal with some other metals like tin is called as tinning, zinc is called as galvanizing, chrome plating, aluminum plating. You can do it. Chromium metal, aluminum metal, if you give the coating on it, you can prevent the rusting. So they are some of the methods of prevention of rusting. With this, we will move on to the last part, that is rancidity of oils and fats. Right? Rancidity of oils and fats. What is rancidity? Last part, I will finish it today. Rancidity. What is rancidity? Rancidity means whenever you keep any oil, edible oil, any oil exposed to the moist air for a long period, any oil or fat, edible oil or fat at home, if it is exposed to air for a long period, it will develop a bad smell. This particular process is due to oxidation again. All these are effects of oxidation. Even rusting of iron, tarnishing of silver, conversion of copper to carbonate is all oxidation reactions. Means they will lose electrons converted into ions. They are all neutral atoms. Loss of electron is called as oxidation. And here also rancidity means the development of bad smell. The development of bad smell. When an oil or fat is exposed to air, moist air for a long period, for one season, for a long period is called rancidity. Generally, when exposed to the air, the components will release some substances which have got a bad smell or foul smell. That is called as rancidity. Now the question is how to prevent it. Rancidity can be prevented by different methods, by packing in airtight bags. One of the method of prevention of airtight containers. storing them in containers, and then boiling and storing in refrigerator, boiling, cooling and storing in refrigerator, storing in refrigerator. Another method of prevention of rancidity. And even you must have, you are using, you are very, you like chips, potato chips. Potato chips bags will contain only 5 to 10 chips, but bag will be big. So why this particular bag will be big? Because in that potato chips bag, they will fill nitrogen gas. Because of filling nitrogen gas, the potato chips will not get oxygen. So that potato chips will contain oil in it. If they get oxygen, that nitrogen gas replaces oxygen. They will fill nitrogen gas in it, replaces oxygen. Remember, replaces oxygen, right? And even you can add some antioxidants. Antioxidants can be added to the oil. Antioxidants are added to the oil, like there is one called as BHT, butylated hydroxytoluene, available. Antioxidants are available, you can add it. Or natural vitamin E, if it is present in the oil, such sites generally do not get spoiled. It is a natural preventer of rancidity. So these are some of the methods of preventing rancidity. That completes the chapter, my dear students. Wish you all the best in the preparation of chemical reactions and equations. In the next period on Monday, we will have, and Saturday I will inform you, because I am preparing, I am shifting to, I am going to Gadag now. So there I will set up the same studio there, another studio. I will come live from Gadag. I will let you know by tomorrow afternoon, right? I will take the setup. Tomorrow I will be in Gadag. Now I am in Dharwad. And Gadag students can meet me between 9 to 1 o'clock. There is a workshop. I have sent you in your WhatsApp group. Gadag students can meet me between 9 to 11. There is workshop on Vedims. Download Vedims app, how Vedims works. I will talk about 8, 9, 10 students. You come there. Those who are Gadag local students, Karnataka, Gadag, between 9 a.m. to 11 a.m. There is a workshop, doubt clearance classes, offline. I will be available offline. You can talk with me, discuss with me, and you can share your difficulties, bring your difficulties in maths. I have given real numbers, polynomials, trigonometry. Any doubts are there, you can bring and clarify your doubts. That's all, my dear students. Meet you on Monday, chemistry. About Saturday maths period, I will update you tomorrow afternoon. Bye bye. See you.